In this video, we're going to take a look at creating a wetlands DGN file. We're going to import the wetlands from a .shp file. We will assign a feature definition to those wetlands. Then we will drape them over an existing surface so they can be visualized in the dynamic cross-section viewer. And then the final step will be to hatch all of the wetlands to prepare them for planned production. This video is to supplement the wetlands delineation workflow document. The first thing that we're going to need to do is to create the wetlands DGN file. So from the MicroStation Manager, I'm just going to click New File. And we want to make sure that we are using a 2D seed file. In this case, it would be the mdt-seed2d-imperial.dgn. And we're going to name the file. The prefix will be whichever project number you're working on. And then after that will be ENWSU and then 001, since this will be the first wetlands DGN file. And then we'll just click Save. Okay. And now we'll select our new file and we'll click Open. Okay, now that we have created our wetlands DGN file, we need to attach some reference files to it. We're going to do that by going to the reference icon, which is located on the primary toolbar. And we're going to click the Attach Reference icon. And the first file that we're going to attach will be a corridor file. And corridor files are going to be named with the prefix of the project number and RDCRR001, and if there's more than one, it'll be 002, 3, and 4, and so on. So we'll just click 001, and then we'll click Open. And we'll leave it on Coincident World, and everything else looks good, and we'll just click OK. All right. We can see that reference file right there, and I'm going to go ahead and attach the other corridor file. So click Attach Reference icon, select RDCRR002.dgn. We'll click Open, and the settings should be unchanged from previously, and we'll just click OK. Okay, so now we have our corridor files attached. The next thing we need to attach will be the existing terrain. So we'll click Attach Reference, and terrain files are going to be called, again, the prefix of the project number, RDETR001, 2, or 3. So we'll click that and then just click Open. And again, all these settings should be fine. Let's click OK. So now what we need to do is we need to attach the wetland shapes. Okay? And to do that, we're going to follow the exact same process as attaching a reference DGN, but in this case we're going to select a .shp file. So we're going to click Attach Reference again, and we're going to find our shapefile. There it is right there. Remember, it has the extension .shp. Now you may have to change your filter to all files to make sure that that shows up in your listing, because if you're just on DGN, all you're going to see are DGN files. Okay? So just make sure you switch that to all files if it's not already, and then you'll see all the files in that folder. So I'm going to select that SHP file, and then I'm going to click Open. And we're going to leave all these settings set as they were from the other files, with one difference. We're going to check off 1:1, since the shapefile is scaled a little bit differently. We want to make sure it comes in the right location. So we're going to click off true scale, and then we're going to click OK. Okay, so now we can see that the wetlands have been attached. You can see they got some shapes there. Okay. So in order to work with the wetlands, we need to bring them into this DGN file. Okay. So right now they exist only in this .shp file, and we need to essentially copy them out of that file into the active DGN. And to do that, we're going to use a command that's called merge into master. And we're going to go ahead and turn off the corridor file for now, because we really don't need it at this point. So I'm just going to select that in the references dialog, and then I'm just going to click this display icon, and then I'll shut that off, and then I'll check the other one and shut that one off. Okay, So all that's displayed right now is going to be our terrain and our shapes for our wetlands. Now we want to do a fit all before we do merge into master, because when you do that, it's only going to merge in what is in the view. So if we're zoomed in on this one wetland and then we do merge into master, that is all you're going to get. Okay. So again, we want to make sure we do a fit all. Okay. And it's okay to leave the terrain displayed because we're going to select the wetlands shapefile for merge into master only. So to merge the wetlands file into the active DGN, we're going to select the shapefile. We're going to right click, and from the pop-up menu we're going to select merge into master. And there will be a message down here in the message center that's going to say select view for merge. And to do that, we'll just left click in this view 1 here, and then it's going to tell you you have selected one reference to merge into current design, and we're just going to click OK. Okay, so when that happened, it copied the wetlands into this active DGN and then detached that shapefile. So now all of the wetland shapes are in this active DGN. Kind of zoom around, we can see they've all been copied in. Now that we have the wetland shapes copied into the active DGN file, we can go through the process of creating the wetland boundaries and draping them over the existing terrain. Before we can do that, we're going to need to drop these shapes into individual components, because open roads can't visualize a shape on the cross sections. It doesn't recognize it as a linear element. We're going to use a VBA called the break shapes macro, which will go through and drop all of the shapes into 2 line strings. And then we can assign a feature definition and drape them over the terrain. So before we do that, I'm going to do a fit all again, and we can go ahead and shut off the terrain because we don't really need it at this point. So I'm going to turn off the display of the terrain. So all that's being displayed in the file right now are the wetland shapes. So I'm going to go up to the road tools on the drop down menu, and I'm going to go down to mapping, and then I'm going to select break shapes. Okay. Now when this command loads, it's going to prompt you or ask you to select all of the shapes for processing with element selection. So what we need to do is select all the shapes in the file with element selection. We'll just left click at the top and drag a box around everything, and it's going to say down here in the lower right hand corner 42 elements are selected, and depending on how many wetlands you have brought in, that number will vary. So right now all we have to do is click process, and then command's going to go through and it's going to execute the break shapes VBA, which will break the shapes into 2 line strings. And if we can kind of move the cursor around, we can see that each one of these shapes has been dropped into 2 different line strings. Okay. So we're done with the break shapes macro. We can go ahead and hit the exit button. Now that all the wetland shapes have been dropped into 2 line strings, we can go ahead and assign a feature definition to all of the wetlands. To assign a feature definition to the wetlands, the first thing we'll need to do is use element selection and select all of the wetlands in the file. And then we're going to go over to the taskbar and go to horizontal geometry, and we're going to select set feature definition. And we're going to set the feature type to linear, and we're going to set the feature definition to MDT environmental wetland existing feature. And we don't need to worry about the name right now. Okay. So now at the cursor, the heads up prompt, it's telling us data point to apply feature definition to 84 selected elements. The number of elements or wetlands selected again will vary from project to project. So I'm going to go ahead and left click or data point in the file to apply a feature definition to these elements. Okay, so if we zoom in and take a look at the wetlands now, we can see that they have symbology on them. If we select element selection and hover over it, it will tell us from tooltip that it is a line string and that it now has a feature definition. There's no active profile that will come with the next step. But first, what we like to do is the line style that displays the wetland boundary is built into this feature definition. In order to see it, we're going to need to change the annotation scale to scale the line style appropriately. So we're going to set the annotation scale to 1 to 100, and our line styles should display properly. To do that, we're going to use the annotation scale or drawing scale toolbox. And if this drawing scale toolbox is not out or docked somewhere around in your MicroStation session, you can get to that toolbox by going to Settings, Drawing Scale, and that'll bring up the drawing scale dialog. And we need to check on the annotation scale lock, so we're going to check that on, and then we're going to set the scale from the drop down to 1 to 100. Okay? Now as soon as we did that, we can see right away that the wetland line style is now displayed correctly. So now that we have applied a feature definition to the wetlands, we can go ahead and drape them over the existing surface. In order to do that, we need to have an active surface. So I'm going to turn the terrain back on, and that's the RDETR file. Let's turn the display back on. To set a terrain as active, you need to go over to Element Selection, and then move the cursor over to the terrain boundary and select it, and then kind of move the cursor just a little bit, call it nudging, and this will bring up the context menu. And from the context menu, you're going to move the cursor over to select the second icon, and that says Set as Active Terrain Model. Now as soon as we do this, let's pay attention to what happens in the references dialog, because this is going to automatically generate the 3D model for us. Okay, so I'm going to select this, just left click or data point on the mouse, okay, and let's set the terrain as active. And from this view 1 or the 2D plan view, we really don't see any change. Okay, but if we look in references dialog, we'll see there is a reference that was automatically attached, and it's the same name as the active DGN file. The only difference is it says default-3D under the model column. Okay? So what happened is the software automatically generated a 3D model and referenced it back to this 2D plan view that we're working in right now. The display of this 3D model is also turned on in this 2D plan view, and typically we'll just shut that off. So we're going to go ahead and select this reference. That's going to be the name of the active DGN file, and it says default-3D under the model, and we're just going to check off the display. Okay. Now what we want to do is we want to display the 3D model in another view. To do that, we're going to right click and hold anywhere in this view, and that will bring up the pop-up menu. So we're going to right click and hold it down, and we're going to go to View Control, then we're going to go to Views 2D 3D, and that will set View 2 as our default 3D view, and then View 1 will remain the 2D plan view. I'm going to change the rotation in the 3D view. So to do that, I'm going to set the 3D view as active, and from the toolbar at the top, I'm going to go to View Rotation. I'm going to click the drop down, and I'm going to set it to isometric view. And that went off the screen. That's okay. We're just going to click the Fit View icon, and that'll bring it back into view. Okay, so now we are ready to drape the wetlands over the existing surface. So I'm going to set View 1 as active, and I'm going to do a Fit All. I'm going to use Element Selection, and I'm going to select all of the wetland areas. And then I'm going to use a command called Profile from Surface. And this is located on the Vertical Geometry tab. On the first row, the third icon over, it's called Profile from Surface. And from the heads-up prompt at the cursor, we can see it's asking us, do we want to apply these 84 selected elements to the DTM profiles? So we're going to left-click on the mouse to accept that, and then it's going to ask us if we would like to locate a reference surface or reset for active terrain model. Our terrain model is already set as active, so we're just going to hit reset on the mouse, and then we're going to accept the following options at the heads-up prompt by just left-clicking on the mouse. So it's asking us for point selection, that's going to be set to all, and then profile adjustment we're going to set to none. Draping option we're going to set to triangles, And then horizontal offset and vertical offset are going to be set to 0. Now after you accept the vertical offset option, the command is going to go ahead and execute. And it may take a minute to process. Okay, and when it's completed, you should see the wetlands over in the 3D view. And it will stay in this command until you clear it out. So let's go over to element selection, click that, and that'll clear out that command. So if we go over to the 3D view and zoom in, we can see that the wetlands have been applied to the terrain and draped over that surface. Let's go ahead and make the 3D view active for a minute. So I'm going to click the bar at the top. That'll set it as active. And we need to set the annotation scale in the 3D view because that is what drives the display of the cells that we're going to see in the dynamic cross-section viewer. So I'm going to turn on annotation scale and I'm going to set that to 1 to 20. Now remember, these two views have annotation scale settings that are independent of each other. So in the 3D view, our annotation scale is set to 1 to 20. If we click in the 2D plan view, we can see that annotation scale switches and now it's set to 1 to 100. So now we can go ahead and visualize these in the dynamic cross-section viewer. And to do that, let's open up the references dialog again and let's turn on the corridors. So I'm going to select the corridor files and turn the display of those on. Now we can see that they're displayed in the 2D plan view, but they're not showing up over here in the 3D model. That's because we need to turn them on in the 3D model as well. So let's go ahead and do that. Let's click the top bar here and make the 3D model active. And let's select corridor file and turn the reference display on. And let's select the other one and turn that one on as well. Okay. We can go ahead and close out of that for now. And let's go ahead and make the 2D view active again. And if we navigate around the 3D view, we can see the corridor shows up in the 3D model, and we can also see our wetlands in the 3D model as well. I'm going to zoom into this location up here where the wetlands are, and I'm going to open up the dynamic cross-section viewer, and to do that we're going to go to the corridor modeling tab and we're going to select open cross-section view. Now the heads up prompt is going to ask us to locate a corridor or an alignment, so you need either one of those items to open a dynamic cross-section viewer. So I'm going to zoom in a little bit. I'm going to select one of the corridor handles and that will select the entire corridor. So I'll select that. It's just going to ask me to select or open a view, and I'm going to turn on view 3. And right now view 3 is blank until I left click inside this view to activate the dynamic cross-section viewer. So I'm going to do that, and this may take a minute to process. I'm going to move it over to here, and when it's finished we'll see the cross-section at the beginning of the alignment, in which in this case is 190 plus 0, 0, and we can see the corridors displayed and the existing surface is displayed. We don't see any wetlands right now because we're not at a location where the wetlands are. So to navigate to where the wetlands could be, we're going to right click and hold down in the dynamic cross-section viewer, and that'll bring up the pop-up menu. And we're going to use a command that's called locate station via data point. So we'll left click that, and we'll go back over to our 2D plan view. So at the cursor it's telling us select plan or profile view. So I'm going to left click in here, and when you do that you're going to get this dynamic dashed line running perpendicular to the alignment and the corridor, and it's allowing you to either data point in the view to select a location, or you could just key in the station if you know what the station range was. We're just going to data point because I can see the wetlands here, so I'm just going to left click, and then the dynamic cross-section viewer will move to that location, and we can see the wetland boundaries are displayed in the cross-section view. So now that we have displayed the wetlands in the dynamic cross-section viewer and they're displayed properly in the plan view, we can go ahead and move on to the final step, which is to hatch all of the wetland areas and get them ready for planned production. Before we close out of the dynamic cross-section viewer, we want to make sure that we do it in the proper way so it doesn't cause any issues in the file down the road. So it's best practice to use a tool called Copy View. To do that, we'll go up to Tools, View Control, Copy View. And we're just going to select the 2D plan view, and then we're going to pick in or select View 3. Okay. Now that that dynamic cross-section viewer has been cleared out, we can go ahead and close View 3. And that brings us back to just having the default View 1 or the 2D plan view, and then the 3D model displayed in View 2 over here on the right. Okay, so to hatch the wetlands, we can go ahead and shut off the corridor file. It's really just for visualization purposes. We really don't need it turned on for this step. So I'm going to go up to References, and we're going to go ahead and select those references and shut those off. To get the wetland areas prepared for plant production, we need to place a crosshatch inside all of the wetland areas. And to do that, we're going to use a command called hatch area. Before we can do that though, we need to set the element template to set the proper symbology for that hatch pattern. Okay? So we're going to go up to the element template icon, and we're going to click the drop down arrow. Then we're going to go to MDT environmental, and then we're going to expand out wetlands, and we're going to select wetland existing area. Okay? And we notice that set the symbology for any of the commands that we're going to use. So now we're going to bring up the hatch command, and that's located on the drawing tab on the taskbar. And it's the 4th row down. It's going to be the first icon called hatch area. And when tool settings changes, go ahead and click this arrow to expand out the additional options. The method that we're going to use is going to be the flood method. And what that does is when you select inside of an enclosed region, it will go out to find the extents of that enclosed region, and then it will create a hatch inside there. The first setting here is spacing, and this is set to 0.01, and that represents the space between the lines of the hatch pattern itself. And we'll just leave it set at 0.01. And also make sure you check on annotation scale so that the hatch pattern will resize when the annotation scale is changed. The angle is going to be the angle of the crosshatch, and right now it's set to 45 degrees. The tolerance is currently set at 0, and you can adjust the tolerance to a number, say 0.5 or 0.1, and that represents the maximum gap that the software will skip over when it tries to find an enclosed region. Since the wetlands were created from an enclosed shape, we should be okay to leave the tolerance at 0. If you run into problems with it not being able to find an enclosed region, you can start adjusting the tolerance and see if that helps out. And we want to check on associative pattern and associative region boundary. And what that will do is that will associate the hatch pattern to the wetland boundaries. So if any of these change or are adjusted or modified, the hatch will adjust to meet the new limits of that boundary. Down here in the expanded settings, we're going to use locate interior shapes. And this particular wetland that we're looking at right here actually has an interior shape, and I'll go over how that works when I hatch this wetland boundary. Okay, so I'm going to click that on, and you can go ahead and leave max gap at 0.001 and text margin at 0. So now all we have to do is left click inside the wetland boundary. Now it's important that the wetland that you're hatching, all of the extents of it are visible in the view. So if your wetland looks like this and you try and hatch this, it's not going to be able to find an enclosed region. So make sure that the wetland that you're hatching, the entire wetlands are visible in the view. So I'm just going to left click inside the wetland, and it's going to dynamically select the boundary that it has found. Okay? And then you're going to left click again, and it will go ahead and hatch that wetland. And you're going to repeat that same process for every wetland boundary. go ahead and select this one and hatch that one. Now this one right here that has an interior shape, let's see what happens when I select that. Okay. Now we can see that it automatically detected that there was another shape inside there, and if I accept it, it's not going to hatch inside there. After you've gone through the entire file and hatched all of the wetlands, it will then be ready for planned production.